numerators and multiply the denominators. To divide two fractions, you multiply by the multiplicative inverse. Okay? So the multiplicative inverse of that divisor. Okay, that's the same thing as the reciprocal. So if you are dividing fractions, you need to take the reciprocal of that second fraction in order to multiply instead. So here we have multiplication. I'm multiplying 2 over 9 times 15 over 4. You multiply your numerators and you multiply your denominators. Now when they're doing this, they're getting the factors of each. So 2 is just 2. Factors of 15 are 3 and 5. Factors of 9 are 3 and 3. And factors of 4 are 2 and 2. That way they can cancel out like terms. Okay, so I end up getting 5 over 3 times 2, which is just 6. Now if you're dividing fractions, I have 3/5 divided by 6 over 35. You need to find the inverse. You need to take the reciprocal of this second fraction here. Reciprocal of that second fraction and turn it into a multiplication problem. So instead I would have 3/5 times 35 over 6. And again, I can find the factors of the numerator. So 3 is just 3. 35 is 5 and 7. And then in the denominator, 5 stays as 5, and then 6 has a factor of 2 and 3. Okay, that way I can cancel out like terms to end up with 7 halves. So to multiply rational expressions, multiply the numerators and multiply the denominators. So for all rational expressions, a over b and c over d with b not equal to 0 and d not equal to 0, because those would be undefined then, a over b times c over d is ac over bd. Okay, so you just multiply numerators, multiply denominators. Okay, if we're dividing, again, you have to find that reciprocal of your second fraction so you can multiply instead, and then multiply straight across just like in that first one. So we are just going to simplify our expressions here today. So first thing I do is look to see if I'm multiplying or dividing my fractions. This one I'm multiplying, so I don't need to find that reciprocal. So I'm going to find the factors of my numbers out front. Okay, factors of 6 are 2 and 3. And factors of 21 are 3 and 7. Okay, then I have x, y, and a cubed as well. So I'm just multiplying together everything in that numerator. And I just wrote down the factors of each of those numbers. Okay, that's over. Factors of 15, that's 3 and 5. Factors of 18. Okay, that's 9 and 2, but I also have factors of 9, right? So if I split this into 2 times 9, I would have 2 times factors of 9 are 3 and 3. So that's how I would factor out 18. Okay, and then I can multiply in my variables. So I have a, b squared, x to the 4th, and y. Okay, I'm writing out these factors so I can cancel out like terms in the numerator and denominator. So here in the numerator I have a 2. I also have a 2 in the denominator. Those will cancel. I have a 3 and a 3. And I have another 3 here. Okay, I have 2 y's. Yep, so I can cancel out those y's. Now with my other variables, I have an a cubed over an a. Okay, so the 1 in the denominator will cancel. The 1 in the numerator will change to a squared. Okay, so if I cancel out one of those a's, I now have a squared instead of a cubed. Okay, same thing with your x's here. So I can cancel out the 1 in the numerator, and then the 1 in the denominator would be x cubed instead of x to the 4th. So now I can rewrite my fraction with what I have remaining. So I have a 7 and an a squared in the numerator. And in the denominator, I have 5 and 3, so multiply those to get 15. And then I also have a b squared and an x cubed. Now, after I write this out, I always make sure I can't reduce it any further. Okay, I can't reduce 7 over 15. I don't have any a's in the denominator to reduce that numerator. And I don't have any b's or x's in the numerator to reduce that denominator. So this would be my final answer here. Okay, questions on letter A? All right, then we're going to do the same thing in letter B. So this time, I see that division symbol. Okay, if I see that division symbol, that means I need to change my second fraction. So my first one stays the same. But now I want to multiply by the reciprocal of that second fraction instead. So the reciprocal of that second fraction is 7a squared b squared over 24m cubed. So I'm just changing that second fraction to multiply by the reciprocal. So now I want to do the same thing I did in letter A. So I want to find the factors of my numbers up top here. So 16 is 4 times 4, right? Okay, but 4 is 2 times 2. And then I need another 4, so 2 times 2 to get 16. Then 7, its only factor is 7. So I multiply by 7. And then my variables in that numerator multiply together as well. So m t squared, a squared, and b squared. Okay, we'll do the same thing in the denominator. So factor 21. That's 3 times 7. Okay, factoring 24. Okay, that would be, we can say 12 times 2. So I would have 2, right? And then 12 is 3 times 4, right? So we have 3 times, and then the factors of 4 are 2 and 2. Okay, so I factored out 24 to its prime numbers there. And then again, just multiplying in my variables. So a to the 4th, b cubed, and m cubed. And from here I can just cancel again. So I have a 7 and a 7. Okay, I have 2 and 2. I have another 2. And I have a third 2. Okay, so that's all for my whole numbers out front. Next, I'm going to move on to the variables. So I do have m over m cubed. So that numerator m will cancel out. And then in the denominator, I would only have m squared then. I have a's. Okay, so I have a squared in the numerator and a to the 4th in the denominator. So it cancels out in the numerator. What's left in the denominator then? A squared. Okay, and then same things with the b's here. So we have b squared and b cubed. So I would be left with b in that denominator. Okay, so I can rewrite my fraction now. Okay, I have a 2 and a t squared in the numerator. Okay, I have a 3 times 3 in the denominator, so that's 9. I have an a squared. I have a b, and I have an m squared. Okay, and then again, just make sure that everything is simplified down before you circle or box your answer there. In this case, it is. I can't reduce anything more, so that would be your final answer. Okay, questions on A and B, multiplying your or dividing your fractions. All right, then example 2, we can do the same thing with expressions. So yesterday we factored and then we canceled things out. We're going to do the same thing today. You're just multiplying 2 together. Okay, so you're still factoring it and canceling it out. So in letter A here, I want to factor each of these. Okay, for that numerator on the left-hand side. Okay, what can I take out from both of those terms? What can you take out from both of those terms there? Anyone? 4. And I'm left with 2x minus 5 then.
Thank you.
Okay, then the denominator, we can factor that one as well. So I would use the x method. So what adds to 2 and multiplies to negative 35? That's 7 and negative 5. So I would write this as x plus 7 times x minus 5. Okay, I want to do the same thing with the other fraction then as well. So in the numerator, I can use the x method. So I have what adds to negative 7 and multiplies to 10. That is negative 5 and negative 2. So I would write that as x minus 5 times x minus 2. Okay, in the denominator of this one, I have 2 terms. What do both of those terms have in common that I could pull out? 4. Okay, so if I take out a 4, I'm left with x squared minus 4. I can still factor this. Do you remember how I factored that yesterday? If I have perfect squares for the first term and the last term, and there's subtraction between, we factor that into the plus and minus quantities. Okay, so perfect squares, I can take the square root of both, and I have subtraction between, we split that into plus and minus. So this would be x plus 2 and x minus 2. And you do need to take the square root of each of those terms to find these here. So that's how I would factor that denominator. So now I have 4 times x plus 2 times x minus 2. Okay, from here, since we're multiplying straight across, I can start canceling because my fraction bar will just extend. Okay, I'm just multiplying all those together. So we want to see what's the same in the numerator and denominator. Well, I have a 4 over a 4. That cancels to 1. I have an x minus 5 over an x minus 5. And I have an x minus 2 over an x minus 2. Okay, and then all I have to do is rewrite my fraction. So I would have 2x minus 5 over x plus 7 times x plus 2. And that would be my final answer. Okay, questions? Questions on letter A? All right, then letter B is the same, except this time you're dividing your fractions. So if you have a division symbol, do you remember what I did on the front? What did I do on the front? How do I change this? You flip it. So I would have x squared minus 9x plus 20. So keeping my first fraction the same. And I want to multiply by the reciprocal instead. So I need to switch my numerator and denominator. So I would have 6x plus 42 over x squared minus x minus 12. And from here, we just factor like we did in letter A. So I want to factor my numerator. So again, I can do the x method off to the side. What adds to negative 9 and multiplies to 20? That's negative 5 and negative 4. So I would factor that numerator into x minus 5 times x minus 4. Okay, next I want the denominator. So factoring the denominator, using our x, adds to 10, multiplies to 21. That is 7 and 3. So I would have x plus 7 times x plus 3. Okay, next I can factor my second fraction. So this one only has 2 terms, so I always see if I can factor anything out from both of those terms. That's the same. So both of those have a 6, so I can factor out a 6. And I'm left with x plus 7. Okay, that's over. Again, I have a quadratic here, so I use the x method to factor that one. So what adds to negative 1 and multiplies to negative 12? Negative 4 and 3. So I have x minus 4 times x plus 3. And again, from this point, I can cancel out if I have similar quantities in the numerator and denominator. Okay, so in my numerator and denominator, I have an x plus 7. So those would cancel. I have an x minus 4. So those would cancel. Okay, then rewriting my fraction, I would have 6 times x minus 5. Don't lose that 6. Okay, it's still there. Over x plus 3 times x plus 3. Now you can keep it like this, that's fine. Or you can write it as 6 times x minus 5 over x plus 3 squared. Okay, that's the same thing. So if you notice you have 2 of the same quantity, it's a squared quantity. So that doesn't matter which way you write it. I'll accept either. Okay, questions on letter B on the back?